Bismillah ar-Rahman ar-Rahim. We'll continue. So now we'll talk about, now what we did in the first video, just the terminologies or the basic things is the meaning linear, homogeneous, non-homogeneous, superposition principle for the homogeneous. If you have a solution, then a linear combination is also a solution. Existence and uniqueness, I need the functions. After writing it in standard form, after writing the differential equation in standard form, I need all the coefficients to be continuous functions, so I can get the interval. How to verify their solutions if they are satisfying the equation. Then we move to dependence and independence. To prove they are dependent, just you need to find the C's, non-zeros, non-zero C's, so that the linear combination of those functions is equal to 0. Otherwise, if they are solutions, then we can do the Wronskian. You can use the Wronskian. If the Wronskian not equal to 0, then they are linearly independent. Otherwise, the Wronskian is equal to 0, then they are linearly independent. And I think we did good number of examples. That will lead us to this one. The general solution of homogeneous equations. If I have nth order differential equation, this is nth order, but I have the n derivative. Okay. I need to find n solutions. This is the number n is important, and they are linearly independent solutions. N linear independent solutions. If I can find n linear independent solutions, then right away my general solution will be y of x, or what do you call it, c1y1 plus c2y2 plus cnyn. That will be the general solution of the differential equation. Okay. Now, example, I have these are solution. This is given information. These are solution. So we can say in every solution can be written in this form, a linear combination of those. When I can say these are bases, they are bases if they are linear independent. I need to prove they are linear independent. I have y1, this is given, and y2. These are solutions. You can check this one easily. I think we did something similar. Now we need to prove they are linear independent. So we'll do the Wronskian. I have 3e3x minus 3e3x. That give me minus 3 e to the power 0. Okay. And minus 3. So it's minus 6, which is not equal to 0. So that means in y1 and y2 are linear independent. Let me go back. I have this second order. The equation is second order. Okay. And I have two linear independent solutions. I have two linear independent solutions. I have n is 2 linear independent solutions, which is y1, y2. General solution, y will be c1, y1 plus c2, y2. Not only that, the basis for the solution space of this differential equation is y1, y2. These are the bases. Okay. Now we need to do this problem. Show that the three solutions are linearly independent. It's given there are three solutions. Information is given. Y1, Y2. You can check it easily, actually. Are solutions. This is given. I need to prove they are linearly independent. How to prove they are independent? I'll do the wrong scan. And do x 1 0 x ln x. That will be x squared. That's easy. X ln x, it will be a product. I have derivative of, yeah, x derivative of ln x 1 x over x plus ln x. Then it will be 1 over x. Then I'll do the expansion with the first row. I have x. I have 1 plus ln x, 2x, 1 over x2, minus 1. This cancelled. X ln x, x squared, 1 over x2. That give me what? X. I have 2 plus 2 ln x, minus 2, minus 1, 2x ln x, minus x, so it will be minus x, yeah. That give me what? 2x. Actually, 2 cancelled with 2. This is خلاص. So you have 2x ln x, minus 2x ln x, plus x, which is x. Note he wrote x is positive, so this is not equal to 0. So for sure, in the y1, y2, y3 are linearly independent. Okay. Yeah, by the way, why he write x is positive? Because if you notice, this is the differential equation is what? Y triple minus y double 1 over x here plus 2 over x squared minus 2 over x cubed is equal to 0. So this has a solution, has a unique solution. I need these to be continuous, these functions to be continuous. So I need x not equal to 0. But since this is 1, I'll choose the interval 0 to infinity. That's the way to think about that. Okay. Now, let me have a new page. Okay. Now I prove they are linear independent. That means since they are linear independent, I have third order differential equation, third order. You know what, I'll do it here. This is third order. And I have how many? I have 3 linear independent solutions. Y1, Y2, Y3. Right away, I can write general solution is y equals C1, Y1 plus C2, Y2 plus C3, Y3, which is C1x plus C2x ln x plus C3 x squared. All right. Yeah, x ln x and x squared. Now I need to find the c's satisfying these conditions, which are, now I have y at 1 equal 3. Now what's the initial value problem? The initial value problem will be x cubed plus 2xy prime minus 2y equals 0. And they have the conditions y at 1 equal 3, y prime at 1 equal 2, y double prime at 1 equal 1. And now I have this general solution. That's the general solution. So I need to find the c's. I need to find the c's. This is the general solution, actually. So substitute y at 1 equal 3. That implies what? 3 equals C1 times 1 plus C2 1 ln 1 plus C3 times 1 cubed, which implies C1 ln 1 is 0 again, plus C3 is equal to 3. Okay. I need to find y prime. Yeah, I need to find y prime here. Y prime will be what? C1 plus, this is what? 1 plus ln x. So it will be C2 plus C2 ln x plus 2 C3x. I need to find y double prime also. That will be what? C2 over x plus 2C3. Okay. Now y prime at 1 equal 2. Sorry. That implies 2 will be C1 plus C2 plus C2 ln 2 plus 2C3 times 2. In other words, I have C1 plus C2 times 1 plus ln 2. Is it? Yeah. Oh, sorry. This is at 1, not at 2. The x is 1. X still is 1. So that will be C1 plus C2 plus C2 ln 1 plus 2C3 times 1. So that will be what? C1, this is 0, plus C2 plus 2C3. That will be equal to 2. Okay. Now let me move to the last one. Y double prime equal 1 at 1. So substitute. I have 1 equals C2 over 1 plus 2C3. So I have C2 plus 2C3 equals to 1. I need to solve these three equations. Try to do it any way you like. Maybe there is a quick notice. This is 1, which is similar to this. So from there, I get C1 plus 1 equal 2. So C1 equal 1. If C1 equal 1, plug it here. I have 1 plus C3 equal 3. I'm getting C3 equal 2. Plug it here. I have C2 plus 4 equal 1. So C2 equal minus 3. So it will be my solution. Y will be C1 x. C1 is what? 1. So it's x. C2 is minus 3. Minus 3x then x. And C3, what is it? 2 plus 2x squared. That will be the answer. X minus 3x then x plus 2x squared. So that will be my solution. Now, for the non-homogeneous case, where I have the right-hand side is non-zero, I have into all the linear differential equation. We need to work first with the associated homogeneous equation, where the right-hand side is equal to 0. The same equation, but the right-hand side is equal to 0. And from there, I will get the general solution for the homogeneous, where I have n linear independent solutions with the associated homogeneous. So I get what's called YC. This is YC, we call it C1 Y1 plus Cn Yn. But I have n linear independent solutions for the homogeneous one. Then what I will do, I will find a particular solution for the non-homogeneous. Then from this one, I get Yp. So the general solution for non-homogeneous will be Yc plus Yp. Where Yc is what they call it complementary function. This is Yc. C1y1 plus C2y2 plus Cn Yn. And the Yp is just a particular solution for the non-homogeneous. So if I have a non-homogeneous equation, what's the procedure? First, I will work out the associated homogeneous equation. I'll try to get n linear independent solutions since it's nth order. Say this. So I get yc, where c1 arbitrary constant. Then I find a particular solution free of any constant. That's a really good particular solution. Call it yp. Then the general solution yc plus yp. Okay. Yeah. Find the general solution of this. Given what? Given yc is the general solution for homogeneous. And I have a particular solution. So what is the general solution for this equation? For this equation, non-homogeneous one. For the non-homogeneous, this is the non-homogeneous. Since the right-hand side is not equal to 0. Right-hand side is not equal to 0. It's not, it's homogeneous. So the general solution will be y equal yc plus yp. Later we'll tell you method how to find it, but now not for this one, for constant with constant coefficient. But now just we want to fix this basic idea. So you have this is yc plus yb, which is minus. It's evident that yp is a particular solution. What they mean by yp is a particular solution? Also here, this is why it's a particular solution. It satisfies the equation. That's it. So I know in yp prime will be 0, and it's equal yp double prime, yp double prime, triple. Put it in the equation, left-hand side, I have 0, 0, 0, minus 2 times minus half, which is 1, which is the right-hand side. That's what they mean, it's a particular solution. So also the same thing. He said, this is clearly, it's a solution. Yeah, why is that? Because yp prime is 3, yp double prime is 0. Plug it here. You have 0 plus 4 times 3x. This is the left-hand side. For sure, it's equal to 12x, which is the right-hand side. That's it. So it's a particular solution. And I have yc is a complementary solution. So what will be the general solution for the non-homogeneous? The general solution for the non-homogeneous will be y equal yc plus yp, and that will be c1 cosine 2x plus c2 sine 2x plus 3x. Now, he said find the solution, satisfy the initial condition. Now we need to work out the initial condition for this general solution, which has the yp also. So I need to find y prime because I need it here. So it will be y prime. It will be minus 2c1 sine 2x. And this will be plus 2c2 cosine 2x plus 3. I know y at 0 equal 5. That implies what? 5 equal c1 cosine 0 is 1. Sine 0 is 0 plus 15. So I have c1 plus 15 equal 5. It? No, sorry. It's x is 0. So plus 3 times 0. Yeah. So that implies 5 equal c1. That's it. Or c1 equal 5. Let me write it. C1, this is 0, 0 equals 5. I did the second one. Y prime at 0 equals 7. What I will get? 7. I'm plugging 0 here. It's minus 2c1 sine 0, which is 0, plus 2c2 cosine 0, which is 1, plus 3. So I have what? 2c2 2c2 equal what? 7 minus 3. So c2 will be equal to, this is 4, c2 equal to. So now what will be my solution? solution. Y equal C1 is 5, so that will be 5. I plug it here. 5 cosine 2x, and C2 is 2 plus 2 sine 2x plus the particular one, which is 3x, and that will be my solution, which is this one. Okay. Solve this initial value problem given what? Yeah, it's the same. Given this is a particular, this is YP, and that Y1, Y2 are linear independent. From here, of the associated homogeneous, I'm getting what? YC. YC would be C1 Y1 plus C2 Y2, which is C1 cosine X plus C2 sine X. What will be the general solution for the, let me call it 1, for this non-homogeneous equation? Call it 1. For 1, the non-homogeneous equation, y will be yc plus yp. And that's C1 cosine X plus C2 sine X plus 3x. I need to find y prime. That will be minus C1 sine X plus C2 cosine X plus 3. Now, what are the conditions? These are the conditions. Y at 0 equal to, let me do it quickly. That implies 2 equals what? Cosine 0 is 0, is 1, so it will be C1 times 1 plus C2 times 0 plus 3 times 0. So I have C1 equals 2. Y prime at 0 equal minus 2, like the one I did. Minus 2 will be what? Substitute here. Minus C1 times 0 plus C2 times 1 plus 3. So I have C2 equals what? 3 minus minus 2, which is 5. Is it 5? Yeah. 5 or minus 5. 2. Now this is derivative minus C1 sine X plus C2 cosine X. This is plus 3. So substitute at 0. Cosine 0 is 1. This is minus 2. Y prime is equal to minus 2. So it's 5, not minus 5. So right away, the general solution will be Y, or the particular solution. Now it's a particular solution. It's not a general solution anymore. Only the particular solution. So the solution, Y will be 2, this one, 2 cosine X plus 5 sine X plus 3x. So this should be plus, sorry about that. Okay, this problem is just an example which cover what we did. Okay, so let me do it step by step. Consider the linear, this is non-homogeneous equation, call it 1. Okay. Show that these are solution. How to show they are solution? We know how to do that. I need to check y prime and y double prime. And check left-hand side equal right-hand side. It's from the homogeneous, which is this one. I want to check its solution of this homogeneous. So now I have left-hand side, y1 double prime minus 16 y1. y1 double prime is this. y1 is e to the power 4x, which is equal to 0, which is the right-hand side. So it's very clear y1 is a solution. Same thing with y2 is minus 4x. So y prime, second derivative, minus 4e minus 4x. y2 double prime, it will be 16 E minus 4x. Now left-hand side, y2 double prime minus 16 y2. That will be 16 e minus 4x minus 16 y1, which is e minus 4x, which is 0, which is the right-hand side. So very clear, y1 and y2 are solutions of the homogeneous. Okay. So the general solution for the homogeneous is y equals c1 y1 plus c2 yc, y2, what we call it yc. Not, I mean, no, not now. First, I need to prove that they are linearly independent. So that the general solution, I need this step to show that they are general, I mean, they can form the general solution. They're not being solution, but they need to be linearly independent. And 2 for the second order, 3 for the third order, and so on. So I have to show they are linearly independent. I'll do the Wronskian. It's already proof they are solutions. This is minus 4 is minus 4x. That will be minus 4 minus 4 is 4x times is minus 4x. It will be e to the power 0, which is 1 minus 8, not equal to 0. That implies y1, y2 are linearly independent. Find the general solution. Now I can form the general solution. What will be the general solution? I have second order, and I have two linear independent solutions. The general solution, y equals c1 y1 plus c2 y2, which is c1 e to the power 4x plus c2 e minus 4x. I want to solve this initial value problem, which is the homogeneous equation with some initial conditions. So I need to find the c's. Okay, so we'll do this. Y at 0. I'm talking about yc. Huh? Here it's about the yc, the general solution for the homogeneous. Y at 0 equal 1. So we have what? 1 equals c1 plus c2. So the equation is, I can rewrite it in this way. Second one, I need y prime. What will be y prime? It's 4c1 a 4x minus c2 minus 4c2 a minus 4x. So I have what? Y prime 0 equals minus 8. So I have minus 8 equal 4c1 minus 4c2. In other words, I have 4c1 minus 4c2 equals minus 8. So I can multiply by 4 the first one, and I just add it to the second one. So I have what? 8c1. This is cancelled. Will be what? Minus 4. So c1 will be minus half. Now substitute there. I have minus 1 plus c2. It will be y equal c1, which is minus half, e 4x, c2 is 3 over 2, is minus 4x. Okay. Now we'll move to the questions about non-homogeneous. In this case, you can find the particular solution by guessing. If you notice, if I have y equal IP equal what? I want 32, I'll multiply by 2x or minus 2x. Since yp prime will be -2, but yp double prime will be 0. So this is 0. Minus 16 times minus 2x will be 30x, 32x. So this will be my guessing. So by guessing or by inspection, that will be my particular solution. Now, what will be the general solution for non-homogeneous? Right away, y equal yc plus yb. That's c1 e 4x plus c2 e minus 4x minus 2x. That will be the general solution. Yeah. Now we'll move to the linear homogeneous equation with constant coefficients. Now, how to solve the equation? Now, we already built the theoretical part. Now, how to solve those equations? Assume I have, now we'll start with, actually, this is what we'll do, constant coefficients. All the coefficients are constant. What's the idea? I think we did that in section 1.1. Also in the exam, I think there was some questions where I put y equal e to the power rx. I get, notice, this is the equality characteristic equation, the equality auxiliary equation or characteristic equation, which is similar to this equation. Everything is the same. Just I'm changing the n derivative to r to the power n. To r. Y, n derivative r to the power n, first derivative to r, second derivative r square, and so on. Yeah, notice that we can derive the auxiliary equation from the differential equation right away. No need to do this step, which is we did, I think, in chapter 1. Also, there is another way to write the equation, which is through the operators. This capital D is just an operator. It's when I operate D on Y, I'm getting Y prime. Okay, so the second derivative will be D square Y. The third derivative will be D cubed Y, and so on. The n derivative will be D capital D to the power ny. This is just an operator. So the equation, this equation, I can rewrite it in this way. An capital D instead of y to the power n, capital D n operating in y. This one operating in y. So I can take y as a common factor. Or I can take y before this. I can take y as a common factor. So I have this as what? An capital Dn plus an minus 1 capital D n minus 1 plus a1 capital D plus a0. I operate all of this in y. That will be 0. That's another way to write the differential equation. It's just a different way to write the differential equation. So I have L of y equal 0, where this is L. This is my L. So the idea, instead of dealing with the differential equation, I will deal with the operator. So it will make it easier for me. Yeah, not in this course, but in other advanced courses where you need to deal with the differential equation in more details. But this is mainly the idea. For us, it's another way of rewriting the equation. If instead of writing it this way, I write it in terms of operator. Okay. Now the main idea, after I get the auxiliary equation, this is an auxiliary equation, I have three cases, three possibilities for the solutions. I have either real distinct, the roots, I'm talking about the roots, are real distinct, or they are non-real, or they are repeated. For the repeated, you can deal with the repeated real and the repeated non-real. They are the same, but our book is doing it this way. So actually I have three cases, but now we make it four cases. If they are distinct real roots, my solution, e to the power r1, e to the power r2, e to the power rk, x. And then I can, these are the solutions, and they are linearly independent for sure. Now C1, I add C1, C2, and so on to make the general solution. If they are repeated roots, real, repeated, then that repetition, I will add, then this times I have e to the power rx, then I have x e to the power rx, x squared, if it is k time, until I reach x to the power k minus 1 erx. These are the solutions. Then I combine it with the seeds, like a linear combination. And the above one, I have ER1, ER2x, and ERKX. Now, if I have non-real, then will be my root, alpha plus or minus I beta. So I have real part, imaginary part. Right away, my solutions are what? E alpha x cosine beta x. This is my first solution. My second solution, the same one, but with sine beta x. If it is repeated, this is the fourth case. If this is repeated, alpha plus or minus beta I beta repeated, then I have E alpha x cosine, E alpha x sine, and then x times that. Because of that, I told you actually there are 3 cases, not 4 cases, but this is the way the book is making it. And e to the power alpha x times x sine beta x. And then until I reach x to the power x minus 1 e to the power alpha x cosine beta x. And don't forget, I have the one with the sine. Then I need to make it, I need to add these C1, C2, make it a linear combination in the form of linear combination. That's mainly the idea. So we'll solve the characteristic equation, we'll find the roots, then we have these 3 cases. We solve this characteristic equation, we have the differential equation, we make the characteristic equation, we have the cases, real distinct, non-real, repeated real, repeated non-real. Actually repeated in general, multiplied by x squared and so on. Okay, so let me do examples. So the first one, I need to solve the auxiliary equation. Let me do this. What will be the auxiliary equation? Right away, auxiliary equation, that will be 2r squared minus 7r plus 3. That's it. So I need to equal 0. I need to factor this. This is 2r. I need 7. That will be 3. That will be minus 1. Just need to factor it, like what we did in the prep here. Okay. So I have 3 minus r minus 6r minus 7r. So I have r equal half and r equal 3. So they are real and distinct. So right away, my general solution, y equals c1 e to the power half x, the first r1, this is r1, this is r2, plus c2 e3x, which is this one. Another example, I have the auxiliary equation. I have r squared plus 2r equals 0, which I can solve it, r times r plus 2 equals 0. So I have r equals 0 or r equal minus 2, r1, r2. So what are the solutions? The general solution, last general solution, y equals c1 e to the power 0x plus c2 e to the power minus 2x. E to the power 0x is what? 1. So I have c1 plus c2 is minus 2x, which is this. Also, we can link it with the initial value problem. So I need first to solve to find the general solution of this. So I have the auxiliary equation. R squared plus 2r plus 1 equals 0, which is r plus 1 all squared equal to 0. So I have r equal minus 1 to minus 1. So what is my solution? General solution. Y equals c1 is minus x plus c2 x is minus x. Now I need to apply the condition to find the constant. Yeah, so to find the c's. So I need y prime. That will be minus c1 is minus x. This one c2 is minus x minus c2 x is minus x. So I apply the condition y at 0 equal 5. That implies what? 5 equal, apply it here, C1 times 1 plus C2 times 0 times 1. So I'm getting C1 equal 5. Done. Y prime at 0 equal minus 3. That implies what? Minus 3. Let me do it quickly. Minus C1 plus C2. This one will be 0. So C1 is 5. So I'm getting C2 equal minus 3 plus 5. This will be minus 5. Take it the other way. 2. So my solution will be 5 is minus x plus 2x is minus x. Yeah. There are many other problems. Yeah, I think I will stop here and then I will do more problems later. Yeah. I'll stop the recording. Thank you.